So, the next technique for representing data we'll have a look at is histograms. Now, you might recognise this already. And you might think, oh, I see, that's a bar chart. Maybe bar charts are linked to histograms. Well, I'm afraid you're wrong. This is not a bar chart. This is a bar chart with gaps. This is a histogram, and a very boring histogram as well. Bar charts have gaps equally spaced out, and histograms don't. So, why might that be? Well, having them continuous along here allows you to look at continuous data. So, for example, time taken by an activity or distance travelled. Whereas these are separate categories. Now they might be 0 to 4 minutes, 5 to 9 minutes, 10 to 14 minutes, but it's unlikely. They're more likely to be football teams that people support. Liverpool, Chelsea, Arsenal. So, what is a histogram then? And what makes a histogram different from a bar chart? So, well, let's have a look at another histogram that's more interesting to help us work this out. This is a very unusual histogram. Its actual setup is bizarre. But what do you notice about the histogram straight away? Well, first off, the bars are touching, so you know it is a histogram, which is good. And then you hopefully notice they're not all the same width. So, our first thing we should note about a histogram is bars can be different widths. Okay. What's the consequence of that? How does that affect what we do and how it represents information? Let's imagine I'm going to draw an additional bar on the end of my histogram. Here it is. Now, if we think of a histogram like a bar chart, we would say this has the same height as this, so they must have the same frequency. Now that makes sense in the link with bar charts, but something suspicious happens when we realise that this bar is very wide and this bar is very narrow. That has to have meaning. So what does it mean? Well, on a histogram, the height is not equal to the frequency. In fact, the height of the bar chart of the chart is called frequency density. Now your other axis might be something like time or weight or distance. These are continuous measures. Frequency density. It still doesn't tell us much about a histogram. Which of these bars contains more people? That's the question. Well, let's define a histogram then. The area of the bar is proportional to the frequency. The area of the bar is the frequency. Well, let's stop for a second. This narrow bar here, we're going to say has a width of 3. This bar here, the same height, but much wider, has a width of 15. What that means is now is that this bar here is 5 times as wide as this bar and therefore contains 5 times as many people. If we give the frequency density at that point a value of 2, the frequency will be 30. And for the last bar, the frequency will be 6. Now, how am I getting those numbers? Well, what shape are the bars? Okay, so we've got area of a rectangle equals, we'll do base times height, but you can call it length times width if you wish. So now we're changing this to frequency equals, well, it's equal to the width of the interval times by the height, but the height is called the frequency density. So this rule is crucial. A bar can have a frequency 5 times as big but be the same height. Or a bar could be twice as tall and only half the width. So you see this bar here. Imagine if the bar next to it was only this big. The same, that measurement there is the same as this measurement. And then this measurement is the same as this one. You'd have 2 rectangles with identical areas, and therefore you'd have 2 where the frequency matches. So let's try and use this rule now to carry out some histogram calculations. So I've got our first set of data here that we're going to use. You can see we've got speeds, which is a continuous item, and we've got frequencies, so I'm going to write area of bar on top of that to help us out with mine. And I'm going to put width of bar on top of that. So, the question has asked us, work out an estimate for the number of cars with a speed of more than 85 kilometres. Well, there's 2 different ways of doing this question. I'm going to show it to you on the diagram after drawing the histogram. So you've got a visual representation. So here we go. I'm going to need to have 2 axes. And I'm going to go, I always try and go 10 centimetres because it's a nice flexible and easy to use system. And it's big enough to see. Now, this is my frequency density. Now that's not in the table, is it? Okay, I'll have to work that out in a minute. And along here I'm going to do my speeds. Again, I'm going to go 10 centimetres because it's a good number. You can see 10 by 10 fits on an A4 page comfortably. And it will fit in an exercise book as well. Now I'm starting that at 60. And I'm going to end it at 100. And that's speed in meters per second. Look at the numbers on my width intervals. 60 to 100 over 10 marks will go 40 in 10 marks, which is 4 each. What would be a better number to go up in? That's right, it would be 5s. So I'm going to change that and go up in 5s. And I'll have a bit of space on the end. It also means that when I do my 85, that will fit nicely. Now I'm going to plot the width of the intervals and the frequency density. Oh, hang on a second. I don't know the frequency density. Look at the labels here. Let's remind ourselves. The frequency is the width of the interval times the frequency density. So the area of the bar, the frequency, is the width of the interval multiplied by the frequency density. So the answer to the calculation is 15, the frequency. The width of the interval is 5. 5 times what makes 15? So that's 3. I got that from 15 divided by 5. The next one, the frequency is 25. So it's 25 divided by 5, which gives me a frequency density of 5. The next one is 36. Is it divided by 5 again? No, good spot, it's 10. So that's 3.6. A bigger frequency, but a smaller frequency density, because it's wider. And the last one, 24 divided by 20, 1.2. So now we can start to really plot this, and we can think about our scale for our y-axis. So it needs to go up to 5. Now I've put 10 marks, so I'm going to put 5 at the top and go up in 0.5s. I don't have to mark every number, I just have to show what the scale is. So the first bar is 60 to 65 and it's 3 tall. So I'll go to 65 and I'll make it 3 tall. Next one is 65 to 70 and 5 tall. The next one is 70 to 80. Watch out because it's 2 along the bottom here. And it's 3.6 tall. So there's 3.6. And then the last one, 80 to 100 is 1.2. So here's 1.2. And here's 100. So there is my histogram. You can see there's a lot of data in the middle and there's less data up here, and that's why they've grouped it together. The frequency polygon would show that. If this had been a frequency, you'd see it dropping off like that. But that's not actually true. That's from frequency density, so don't watch that too closely. Now, work out an estimate for the number of cars with a speed of more than 85. Well, 85 is here. Look at this bar and tell me how much of this bar is more than 85. Well, let's do this. 1, 2, 3, 4. and I want 3/4 of that bar, which is 24. So 1/4 would be 6 and 3/4 would be 18. Now, if they'd asked me to find the median, that would be an equally interesting question. That's halfway in the data. And if I add these up, they total 100. Now, that's the first 25, that's the next, first 15, that's the next 25, so that's 40. So it's 10 bits into the next interval is halfway. 10 bits out of 36. That's the fraction of this bar that you need to count. So that bar is 10 wide, so it's that fraction of 10, which is a multiply, so it's 100 over 36. Now, that's how far into this category you need to go. So it's somewhere like here. What you then want to do is add up the frequency all the way up to there, or add up the value along here all the way up to there. So it's 67 up to 70, and then you add on this bit we've just worked out. So the median would be 70 plus 100 over 36, which, checking it on my calculator, is 72.7 recurring meters per second. You may want to watch that section again, especially the bit about getting the fraction of this. We wanted to go from the 40th to the 50th bit, so I wanted 10 out of these. And then the width of the interval is 10. Yeah. That takes us on to our final example, which will hopefully seem all right now. What proportion are between these two values? So, first off, I'm going to set up my table. Frequency densities will put in. So the widths, 40, 20, 20, 60. Now that's what you'd expect, because you'd expect wide categories here where there's less data and more stuff